Hey guys, Miss York the Science Dork here. We're going to be doing a little experiment today. I know that we're not doing it together, but we kind of are. And this is an experiment that you can try at home. So I have a balloon, an empty bottle, see, empty. I have a container, the white container is hot water, and the pink one is ice. So what I'm going to do is I'm going to take this balloon and put it on top of the water bottle. Woo, my goodness. Then I'm going to take this water bottle and stick it inside the hot water, and let's watch and see what happens to the balloon. Give it a minute. Give it a minute. Whoa, look what's happening. The balloon is doing what? That's right, it's expanding. When I put the bottle in hot water, Stella. Sorry, that's Stella. Yep. Hey, Stella. When I put the bottle in hot water, the balloon expands. Think about why that could be, and we'll talk about it in just a minute. Okay, so you see the balloon. Whoa, my gracious. You see it has expanded. Now, watch what happens when I stick the same empty bottle into the ice. Whoop. Whoa. It automatically went down, and if you watch the balloon, you'll notice that it's doing what? It didn't just fall down, but it's sucking in. What is that called? Does anybody remember when something shrinks up? Yep, that's right. It's called contracting. The balloon is contracting when I place the empty bottle in ice, which is cold. So, let's talk about why this could be. Look at it. It's completely flat. Before we talk about it, should we do it one more time? Should we? We should. Briley says yes. Okay, so I'll take it out. You see how flat it is? And I'm going to put it right back in the hot water, which is probably not as hot as it was, but hopefully it'll still work. Let's put it right back in the hot water. Watch this balloon here. Oh my goodness. It is filling up. I'm excited. Are you excited? You should be, because you've been stuck in your house for a while now, and this is exciting news. If you have a balloon, you can definitely do this at home. And if you see, the balloon is still working on expanding. Now, did I put anything in that bottle when I switched back and forth? No, I didn't put anything in the bottle. So what was in the bottle to start with? I showed you it was empty. But what was in there that you couldn't see? Yep, you got it. It was air. Now, it didn't blow up quite as much, but you can still see that it expanded, right? Okay. Now I'm going to put it back in the cold water so we can see it, or the cold ice so we can see it one more time. Let me get a sip of my coffee. Yeah, I still have my coffee even though I'm not at school, don't worry. Alright, switch it back to the ice. Here we go. And you can see it, oh my goodness, see it sucking in like that? See it contracting? That word is contracting, not sucking in. Contracting is the science word for it. And it just keeps squeezing in until there is nothing left in the balloon. Okay? And it goes completely flat. Crazy. Okay, so who can tell me why this is happening? We said, I told you just a minute ago, that there's air in the bottle. That was all that was in there. So when the air in the bottle heats up from the hot water here, what happens to the air? Obviously, it made the balloon expand. So that means the air in the bottle expanded when it was heated up. It was trying to get out, it had nowhere to go except for in the balloon, so it filled up the balloon. Right? The same amount of air was still in the bottle when we put it in the ice. We didn't add any more air, we didn't take any out. I still had the balloon on here. But what happens is cold air makes things do what? Yes, that's right. It makes things contract. So that's why the balloon squeezed up. The cold air kind of shrinks, right? And so, again, it's the same amount of air in this bottle. The air had the same mass in both situations. It's just how the air reacts to different circumstances, different hot or cold. Okay? And so remember, we talked about in class why when engineers make bridges, they leave gaps in between the pieces of the bridge. Remember that? Were you paying attention? Mm-hmm. So when they do that, the reason they leave gaps is because what happens when it gets really hot? Yep, those pieces of bridge expand, right? And so if there weren't gaps, if they were so close like this and the pieces of the bridge start to expand when they get really hot, then it's going to push, and then there's going to be cracks in the bridge. And since they leave gaps, when it gets hot, because it will, they expand and then they just get closer, but they're not squeezing against each other and causing pressure. Now, who can remember the one thing that acts differently when it's heated and cooled? All materials expand in heat and contract in cold, just like we saw with the air, except for one thing. One thing. What is it? I know you know. Yep. Water. So if we had this bottle filled with water and we put it in the freezer, you know what's going to happen. That bottle's going to kind of bubble out. It's going to be all rocky when you try to put it down. That's because water, when it is heated and cooled, it does the opposite. So water expands when it's cooled, which is the opposite. But everything else expands when it's heated. Now I want you to look at the top of this bottle. Look, it's contracting. That cold air is contracting so much that it's pulling the balloon in. You see that? It's dipping down right here. It's pulling the balloon in. So, it's pretty cool. You can try this at home. You do not need to boil the water or anything to do that. I just used hot water right out of the sink. Be careful because it does get hot. My sink does anyway. And then ice. So if you have an empty bottle of any sort and a balloon, you can try this at home. Miss York the Science Dork, signing off.